Uh, in this session, we have two talks. The first one by Maciej Siwek is Despicable machines, how computers can be assholes. So, Olive.
All right. So, can you all hear me well? I'll start with that. Okay, that's perfect. So, first I'll tell a little bit about me, just so you know who I am. So basically, Maciej Siwek, it's almost, you can't tell that's how it's pronounced, seeing how it's written, because that's a Polish name, so they never seem to be pronounced as they're written. So I live in London right now, but work remotely for the company called Rainforest QA, which we kind of do the automation of the web tests. I am a part of data science team there, and I'm more on the engineering side than the math side. So yeah, this talk will be kind of non-technical, which we'll see. It will be obvious, so it will be boring, so I'm sorry about that. We'll be stating all of the obvious stuff, but I really do believe that the things that I will talk about are really important. Okay, now I have to work that way. Okay, so, yeah, how we perceive machines, how humans see machines right now. Basically, for us, they are logical and calculating, so they don't have emotions. They are always using the algorithms that are almost always right, never wrong. They are reliable, and if they make mistakes, because they do from time to time, the mistakes that they do are pretty absurd. So, I mean, we can see on the slide of the translation gone wrong. It was totally wrong, and you can always see that it's wrong. So I think that makes us kind of more inclined to believe in the results that we get, because if there's a bad result, oh yeah, it's like totally easily seen as a bad result. For example, I don't know, there's like visual QA, you ask the machine, oh, how many dogs are in this picture? And the answer is pineapple. Okay, it's absurd. So the mistakes are there, but they are really easily spotted, or at least we think so. So we see them as trustworthy. So there was even a cool experiment pretty recently where people have been locked in an auditorium like that or something like that, and there was an emergency evacuation robot, and people were told that this robot is not working, it's faulty, and they shouldn't follow his instruction, but then they started to push the smoke into the room, and people were panicked and were running away, and they indeed were following the robot. Even if it was like going into like some small corridors, totally opposite of the exit. So people trust machines, and we all do that. So we believe that they are objective and free of any biases, so we can basically, feel that, trust them that they won't, like the results that we get from all the models won't be tainted by human emotions. Or even any biases, like they won't be racist or sexist or something like that. Or at least that's what we believe, right? So that's the one thing. And it's like, it's okay, I'm going somewhere with that. So the machines, we also give them that power. So right now, at least we thought that they will be assistants in the decision-making process. So we will use computers as guidance for our decisions, that they will be helping us to make better and better informed decisions. And that's what we hoped for. Turns out it's more like they are decision makers. So we kind of gave them even more power. Now many of different decisions are made just by machines. They no longer serve the assistant for the human to make decisions. They make the decisions themselves. So few examples, like those computer said so scenarios. You go to the bank or you go somewhere, you want to, I don't know, get a credit or buy something, and you apply, computer says no, and the person is kind of helpless, right? The computer said so, and I can't influence that. So yeah, the computer have a power to decide. And the other example is overbooking, which actually happened to me when I was coming here. So I was supposed to take a flight that was 2 p.m. and I will land here around 5 p.m. But apparently computer decided to sell even more tickets, so the flight was overbooked and I arrived here at around 1 a.m. So I might be a little tired, so yeah. And that happened, because we gave the power to the machines to make decisions. And even if they are supposed to be assistants in the decision making, often people, just from the laziness or the ease of it, rely on those assistants. So we should take them as a factor and think about other stuff and maybe then make a decision. But sometimes it's easier to just, go with what the machine said. So the power of the machines is huge, and the thing that it's on the rise, and that's because of the advances in machine learning. So it's awesome and exciting, right? We are all here because of it. Like, we all like deep learning, especially like that. That's my favorite, and that's what I do. So it's awesome, amazing, and it's getting easier, and that's, I think, also a key to be more careful with them. So we are giving them even more power, enabling them to make even more decisions that they weren't be able to do them before because they couldn't. Now we can just throw everything into machine learning systems through some linear algebra, and we get an answer there. So we basically make a ways for machines to make more different decisions. But there's a hidden cost. We increase opacity at the same time, so the deep learning models are harder to explain, kind of sometimes not even explainable at all. So we can try to do some different visualizations of activations on different layers, but it's hard to tell what's going on inside this neural net, which is like huge, has many different layers. So we are not really sure what's going on inside there, and that makes it dangerous. So we give them the power to decide about our lives, but they are opaque at the same time. So we don't really know what's going on, and I think that provides to be dangerous, or at least we should take extra care. So, I mean, I guess we can all assume that people who will use them are responsible or something like that. Well, turns out that's a direct quote from the article that was recently published. It wasn't peer-reviewed, so. But basically, the article is called Automated Inference on Criminality Using Face Images. And there's this quote. That's how the article begins. We study for the first time automated inference on criminality based solely on still face images. Okay. Which is free of any biases of subjective judgment of human observers. And I thought, like, I saw that and I was, oh boy, I am for a treat with this article. So it was a pretty recent example. It was mentioned in my mainstream press, and they claim to have achieved like 90% accuracy using AlexaNet, which is kind of even better what other people were able to achieve with AlexaNet in case of the gender recognition. So apparently their network can recognize the criminals better than other people can recognize who is a woman and who is a man just from the faces. So probably something is not right here. Probably. So right answers, wrong questions. Basically, the machine learning models will try their best to learn what we throw at them. So we can throw at them anything, and they will try to produce set of features that make them able, that will enable them to classify the data into two separate sets or whatever many sets you have in there. In this article, they had two sets because they had criminals and non-criminals. So you throw the data at it, and something comes out of it. But if there's even if the question is wrong, like if you can't really tell that if somebody is criminal or not from the face alone, which actually has been studied before, and it's been studied for quite a while, and it's been proven to be wrong for a long time. So there's like no way, and it's been studied on humans, and humans are really good at recognizing faces. So I mean, we can argue that maybe the deep learning network is better, but I'm not convinced about that. So we are probably trying to solve the problem that cannot be solved, and we are throw the data into a network, and we will get an answer, but this answer will be probably not that good. So there's a saying like a drowning man will clutch at a straw, and that's what the model will try to do. So even if there are no features like the underlying features, it will try to generate a set of features that will be able to classify to two different classes. But are those classes what we think they are? Are those labels that we put at the end that, oh yeah, this is the criminal and this is non-criminal? Machine learning model can't know that. Like, it can't know that those classes or the class labels are right. It can't split the data into two different classes, but we name those classes, and that's on us. So also I think like there might be many false correlations in there, so we can, for example, see that maybe the model learned some correlation that actually is in those photos, for example, testosterone level or something like that. It is possible, but it doesn't mean that like this is a classifier for the criminality. So yeah, this is an example what the faces looked like in this article. So those were labeled as criminals. Those were labeled as non-criminals. So what I see here is like maybe not smiling or smiling. Kind of, right? They look smiling on the other ones. So I like to smile, so I would be classified as a non-criminal, and that's cool. But maybe that's what it learned. And here I am not like white collar wearer, so maybe I will be even criminal here. So we never know what it learned. We can try, but that's what I see on those pictures. So the data selection can be tainted, and that's what gives us math washing. And this is a pretty cool term coined by Fred Benenson. So basically what it means, we use algorithms and different data, linear data, algebra, or we just throw data at the networks, and we have the result which we think is unbiased, but it will have a bias because the data set was prepared by humans. So it will have our inherent bias, like, I don't know, we chose it wrongly. We have like made a mistake when separating the data. We can't try to avoid them, but there will always be like different biases concerning the data set, because the way we made the data set, it will be biased somehow. So yeah, seeing those results as a free of any biases, just like in this article, free of any biases and the human judgment may lead to abuse, and that's really dangerous, and we should be aware of that. So there is a company that's called, I think, Faceception or something like that. They try to capitalize on something like in this article. So basically they try to recognize the character types from faces, and they will try to capitalize and convince maybe governments or somebody that it can be done. Well, it's really hard to do, in my opinion, and it's near impossible to do correctly and in an unbiased way. So it is dangerous, and we should be aware, and and we should be able to see where it starts to go the wrong way. So yeah, I can't imagine, for example, admission system to the university where you provide your face and it tells, oh, are you smart enough to be a part of our university, which is super bad idea, but maybe it will happen, right? Why not? Why to bother with doing any testing or whatnot when you can just submit your face, right? Seems simple, but it's really not. So even if there is like some easy to spot biases, like you chose the data wrongly, or you partitioned them incorrectly, or you were biased in selection of some class or not, there are always some taint in data, and which is harder to spot. So, for example, the faces which they collected were from the convicted criminals, and here those criminals were convicted by human judges. So we are back on the human judgment, because those classes seem to be objectively coming from somewhere, because it's objective, right? You have the database of convicts, and that's where you pull those images from. So it should be objective, right? But they are there because somebody convicted them and judged them as criminals in the first place. So it might be that there is something that we recognize in faces as a criminality, or maybe not trustworthy, and that makes those judges more prone to judge them as a criminal or not. And that's what the neural net picked up. So, I mean, it's kind of be obvious basically in states. I think it's one of the problems where you have the black people who are convicted at much higher rate with much severe sentences. And if you try to build a data set on this data, which is totally objective, you'll get the same result. Like, you will be more likely to classify black people as criminals, which is totally not true. But another thing that's connected with it is predictive policing. So basically, what they are trying to do in some of the states now is to figure out where to send police patrols. And basically, they try to mostly push the number of arrests or number of people caught doing some nasty things. So it seems okay, kind of objective, right? The crimes happen there, so we should send more patrols there. Seems quite objective for me, but in the end, this data is tainted as well, because in the first place, those arrests happened there because some human decided those are the high-risk areas. So there were more patrols beforehand because some human was biased, maybe or not, sent those patrols there, and that's where there are more arrests in those areas, because there are more patrols there, and it all comes down to somebody somewhere down the lines that thought, oh yeah, we should send more patrols there because those are higher crime rate areas. So right now we kind of math wash it again, see, okay, that's all objective, there are more arrests, and ta-da, we have a system that's totally unbiased, telling us that that those areas are more, there are more crimes in those areas. Another thing that is it's a feedback loop or runaway effect, which is we use this data and then we retrain those networks on the data that comes. So we start with the predictive policing, we start with a human bias, which was already sending the patrols to the different areas. So we use it as a seed data, then we retrain our networks using the basically what the network predicted, where we should send patrols, we send more patrols there, and it kind of creates confirmation bias because there will be more arrests in those areas because that's where we send the patrols, and it happens it goes round and round, and we retrain the network even more on this new data, which was generated by the network, and it goes on and on and on. And I think it's the same case, for example, with the convicted criminals. We can see using this kind of network as an assistant to judges who will be depending on it really heavily. So that might create another bias that more people which had actually those facial features convicted more, and then we retrain the network, and we have this huge mess of bias, which is math washed and seen as an unbiased and free from any human judgment. Okay, so what I really think that's kind of forgotten by the practitioners is forgetting about the societal impact of the models we are creating. So every model we create will influence people's lives. Well, probably every one, maybe not every single one, but we will create models that will have a societal impact. And if when we are creating those models, we can be really kind of locked on them and see, oh yeah, I'm doing better, my classification rate is going higher, and that's cool and awesome, and I'm really happy about that. But forgetting about the bigger picture, how this will fit into society after you are done with your model and you will want to put it to the world for everybody to use. It's pretty easy to forget how it will impact society, because it's kind of obscure in some ways. So, for example, the criminal model as an assistant to judges, well, I mean, it can be seen that somebody will come up with an idea. Maybe we should try to use it as a predictor of how this criminal is really criminalable, and maybe it will help us with the length of conviction, because if he has a face that's faced like he is a criminal, then we will judge him much more severe and lock him up for longer period of time than if he was very non-criminal face. Then maybe it was a mistake, he just slipped up and we should just lock him for 2 weeks or something. Maybe it was a mistake, right? So it is conceivable that somebody might want to use that in this way. And when somebody's creating those models, they don't necessarily think about all those implications that those models might have in the real world. Another one is hiring helper. So that's basically you create a model, a deep learning network to help a corporation with hiring. So you take tons of data about your current employees, take the social media feeds, like every single piece of data you can get on them, and try to learn how it correlates with performance. So you, for example, can have the high performers, take those data about them, and hire just the higher performance people. So it's possible that, because there were articles that point out that you can't predict future depression based on somebody's social media feed. So you can see how they are likely to become depressed soon enough. And it's kind of possible that it might be a hidden feature somewhere in your deep network. You will not know that. Like, it will become emergent from the social media feed or something like that. It will be somewhere in there, and you will not be even aware of it. But is it ethical to then use that classifier? I mean, if it works, if it helps hiring better people, hire better performers. But then we are getting into a great area of ethics, and I think the deep learning and data science is one where we should be concerned with the ethical and societal impact of our work, because every single line of our code can decide about somebody's life. I mean, I wouldn't be able to tell that on the JavaScript conference, for example, so that's why I think it's so important to talk about this stuff here, because it's easy to forget about it. So yeah, future depression as a hidden feature, maybe ethical, maybe not. I'm not here to judge, but it is something to be aware of, that those machines, those models, can learn stuff that's basically not that clear for us in the first place, and even harder to then dig into. Is there a solution to it? Is there a solution to this problem? Because right now I'm kind of shown the dark side of the deep learning and stuff like that. It's pretty great, but is there a solution to this problem which we are facing as a community? I think the one of the best solutions to it is actually awareness. So we should be aware of all those biases and different societal impacts our model might have. So if we know what we are creating and if we are aware of those things, we can try to counteract it, can try to make the users of those models aware as well that this model might be biased in such and such a way. So awareness, I think, is really important, and I think just one of the takeoffs here, just to have somewhere in your mind that those models are biased. Your model is probably biased. I mean, you might try to make it as unbiased as possible, but somewhere deep down it kind of is, and it has this human connection or human judgment built deep into one of the layers. Other thing is, you should always be aware that your models will have an impact on human life. For example, somebody might not have a good night's sleep before his talk. So, yeah, they will impact a human life in a more, like, might be in some small way, but there might be some really huge decisions based on the models that we create, like hiring or admission to university or plethora of different other situations where we actually use the models. So I think those two things, like, if you can remember in the future, there was this guy, pretty tall, which was talking, and he tried to make you aware of those two things, I would be so happy. So remember that your model is probably somewhere biased, and your model will have an impact on human life. So those two things together are quite important. And I mean, I know it feels kind of like, we are technical, why should we care about all this stuff? But I think we are in a place, and especially with data science, that we need to care about it because it's on us. So it's on us to not be just a tool makers that create a model and then just give it to somebody, you use it, and it's your responsibility and your ethical decisions. Like, for example, weapon makers do, right? They make guns, and that's not our responsibility how those guns will be used, right? They might be used for good, they might be used for wrong, but we don't care. And we probably should not go that way, because with guns, at least people understand how they work. And with models, and especially deep learning models, we have a problem to understand what's going on. So, like, somebody who will be using this model is like probably not knowing anything about it. So I think we should act as some kind of educators. So when you create a model, when you ship it, sell it to somebody, ship it to production, make the users of your model aware what are its shortcomings, how it might be biased, in what way it might not do what we advertise, or what might be hidden somewhere on some layer, like the depression feature, which if we tell about it, then it's totally fine, I think, for those people who will be using them to make an informed decision. So, yeah, pretty much it. Thank you for attention. Sorry, it wasn't that technical, but
Thanks, Maciej, for your speech. Is there any question?
Hello.
hi.
First of all, thank you for your beautiful talk. I think the topic is very interesting, actually, and it's very actual, too. So the question is, it's not actually a question, it's more a comment, because I think that actually it's very true that the machine learning these models are biased because our data is biased. But actually, machine learning is telling us something about the bias. So
Yeah.
in principle, if you know that your problem should not be biased, and then you find correlation that you are not expecting, actually you are the answer. You know that we are discriminating by gender or etc. So I think it's we have an opportunity right now that we haven't in the past, because we can actually we can actually demonstrate to people that this bias exists in our data, and so we can, I will not say filter, but at least take in account. Because, you know, for example, in companies, always they use statistics in the way that they want, because they can use a mean instead of another, because it's reflecting better their sales instead. So what I mean is that I think now we have an opportunity. What do you think? You are working on this, on analyzing bias, actually extracting this bias and demonstrate?
No, I'm actually working on something like on deep learning networks, but that's more of a hobby than my day-to-day work that I do. So I use them basically to help automate the tests by classifying the screenshots of web pages. Yeah, I totally agree with you. There was quite recent study as well, where they found they were testing word embeddings, and they found that they are pretty heavily gender biased. And what they were learning them on is actually Google News. So they were learning them on the set of from the newspapers, which should be probably unbiased, but there was like really heavy bias, and it was like sexist bias, right? So they were like really under. I think they're one of those. They were like doing the vector math, and one of the something is to something, like something is to something, and it was like man is to programmer, like woman is to homemaker, which was in there. So I mean, if we are not aware of it, yeah, we can learn these word embeddings and not be aware of it. But if you are aware of those biases and you check for them, then yeah, I totally agree. We can use it as an opportunity to be more aware of where we are introducing biases and where our own biases are coming from. So yeah, I totally agree with that.
More questions?
Very interesting talk. Perhaps this question goes against its very spirit, but are you aware of any mathematical way to characterize this kind of biases?
So yeah, there's a lot of work done right now. So I made it on purpose, not that technical, because I want to be more like humanity-oriented talk. But yeah, there are tons of different research being done on this space. Especially it has to be done right now, because actually even the law regulations. So for example, in the states, you have the law that you can't basically discriminate against any minorities. So they have a law that prevents them from doing that, and then there's a whole tool set on how to change and how to detect if your model is biased in one way or the other, basically on those protected minority criterions. So it has to be done, basically because it's required by law. And I think the other thing that is slowly coming up to fruition is the European Union law about the explainability of models, like right to explain for the models, which is I think actually needed, because so you are aware that your model might be discriminating somebody, and this is like we also need whole tool set on how to check if our models are biased and how to try to explain them. So it might slow down the development, especially of the deep learning, because right now it's hard to make them and like adoption of them. But I think it's kind of needed. So yeah.
Then let's thank the speaker again.
Thank you.